Alright, so this is question 11, bdfhj. So let's look at the left-hand side of B. So for B we've got, let's expand out these brackets. Actually, let's not. Let's do 1 plus, use the identity. 1 plus tan squared we know is sec squared. Okay, so sec squared alpha, and we're multiplying by cos squared alpha. Now sec squared alpha is just 1 on cos squared alpha. So you can see now that, again, I could have done it a different way, but they cancel, which gives us 1, which is our right hand side. Okay, so that works quite nicely. Okay, for D, what do we have for D? We've got a cos squared minus a sine squared. So what we can do is remember that, oops, where's my pen? Sine squared plus cos squared x equals 1. So let's make cos squared the subject, which is 1 minus sine squared x. Let's change them. Instead of this cos squared here, let's substitute in 1 minus sine squared x. So pretend I've already written that left hand side, and now this would be my second line. So you can see I'm going to have 1 minus sine squared is minus 2 sine squared x, which is the right hand side. Okay, F. So F again, we're doing the very similar thing for F. So we've got left hand side equals, and you can see we've got cos squareds, but we want sine squareds. So I'm going to replace the cos squared by 1 minus sine squared. It does have a 3 out the front, so just be aware of that. And then minus 2, so when we expand that out, 3 times 1 and negative 3 sine squared x, and minus 2. So you're going to have a 3 minus a 2, which is a 1, minus 3 sine squared x. And I did it in x's instead of thetas, just so you know. Alright, let's look at H. So for H, let's get rid of that. We've got 1 minus, there we go, 1 minus tan squared plus x squared equals 2. So again, let's use our Pythagorean identity. Maybe we should use, whoops, pen, 1 plus tan squared alpha in this case equals sec squared alpha. So either change tan, well, let's change the sec squared then to 1 plus tan squared. So we've got 1 minus tan squared already, alpha, and then sec squared. So here I'm going to change that to 1 plus tan squared alpha. You can see we're going to get 1 plus 1, which is 2, and minus tan squared plus tan squared, so they cancel. So that just equals the right hand side there, just a nice 2. Alright, the last one for J. So for J, we could do a few different things there. We could use sec squared minus 1. Why don't we do that? So you can see if I rearrange this identity here, I get sec squared alpha minus 1. So I'm going to write that on the side. So that left hand side here, oops, I wrote it up there, it doesn't matter. So I've got cot theta, and then instead of sec squared minus 1, I'm going to write tan squared theta. And of course, cot is 1 on tan, and I'm multiplying by tan or tan squared theta. So one of these is cancelling with one of those, and we're left just with tan theta, which is the right hand side.